This is a review video of trigonometry. In this video, I will tell you, will do a quick review on the definition of some trig function, how to make a graph of this trig function, and how to manipulate them in the way we want. Okay, and so first the definition. So there are three common trig functions that you will use in this course. One is sine, cosine, and tangent. So sine, the definition of sine is, so this is sine, right? Like starting from the angle that you're interested in, you do a sine. And so sine function of this angle would be the opposite over hypotenuse. So this is hypotenuse. And cosine is, let's write a C, wrap around this corner. So it's going to be adjacent over hypotenuse. And tangent, we again starting from this and write out a tangent. So tangent of this angle is the opposite over adjacent. So that's the definition of trigonometry, of this trig function. And now let's talk about how to make a graph for sine function or cosine function. Okay. So a general function, a general sine function will look like this. It's gonna be sine, but it could be, but in front of sine, like you could have some number. And inside of this bracket, it's not always theta. It's not always the angle. It could be a function of, say, time, but in a very special way. Okay, so this is a format that you will see a lot in physics. This is probably another format that you will see in math. Okay, so there's a connection between them. If you remember, if you're some high school math, you probably know that a trig function looks like this. This A, whatever in front of this sine or cosine, this A is the amplitude. And in front of this, the variable they're using, so in math you probably use theta or x a lot. I just use t here, suggesting another variable, but it doesn't matter which symbol I use. And then in front of that, you will have 2 pi over t, where t is the period. That tells you how fast does a trig function could go back to its cycle. And this is what we call a phase shift. Phi will shift where your trig function starts. All right. So this is what you probably have learned in math. If we map it out in physics, the A we still call it amplitude, but this is the amplitude in physics. Okay, I will explain this in a sec. And omega, we call it angular frequency. And if you remember from an oscillation that we learned in last semester, you know that angular frequency, omega, it is 2 pi over a period. So omega is exactly 2 pi over a period. And this is also the phase shift. So this share the same name. Okay, so now you can see a good side-by-side comparison between the math, like a math form, and the physics form. So now let me give you an example. Okay. So now I have a wave function, which looks like 2 sine t. So exactly what's this function look like when I increase t? All right. So to draw a trig function, you must know that a general form for sine will start from 0, it goes up and down. It kind of looks like this form. Okay, so this sine t, like this is a general form for sine. And the maximum value will be 1, because the maximum value amount of value you can get from a trig function is 1. The minimum will be -1, and 1 cycle is 2 pi. So let's come back to carry that knowledge and coming back to this question. This function is the same as this one, right? But I have a 2 multiplied by a 2, which means this function is going to be larger in the y direction. Okay, so the maximum value, instead of 1, the maximum value will be 2, because 2 times 1 at this point would be 2. So if I draw it out, it's gonna look exactly the same shape, but the maximum value now is 2 instead of 1. Okay, so now this kind of tell you the information in y direction. So how about in t, in the time direction? How much is this 1 cycle? Are we doing things differently for this cycle? No, right? So it's 2 pi. You go up and down, come back to itself, it should be 2 pi. All right. So this is we kind of know it, just because based on some fact that we know about the sign. What if I want to calculate the period? Like, just not by looking at this, just calculating this t, this period, and label it out. Then I can do this. So I know whatever in front of the variable that I care about, this whole thing is 2 pi over period. And in this problem, what is in front of my variable? 1, right? There's nothing, but it's like 1 times t. So this is 1. And that being said, is that if you move this, multiply t on both sides, you get t equals to 2 pi. So that tells you 1 period is 2 pi. This is 2 pi. All right. So now let's look at another example. Now this function, it has an amplitude of 2, and it's 2t. Okay, so first it's still a sine wave, so it's gonna go up, down, back, and keep going on. And what's the maximum value? It's 2 now, right? Okay, because the amplitude is 2. How about the period? If we want to follow the math, we can see 2 pi over that period is now, it's whatever in front of t. So in this case, it will be 2. Now that being said, that the t, if I multiply t on both sides and divide it by 2, then I get pi equals to t. So period is pi. So 1 period is pi. Okay. So that's it. Like we have already taken care of this too. Okay. Now let's look at slightly more complicated example. So now my trig function has not only amplitude or the period, we also have a phase shift. And how does that gonna change our shape? So again, let's see, this is a trig function. So no matter what, it's gonna look like this, right? Starting from somewhere, going up, down, and then back. Then just keep repeating itself. And now we know that the amplitude is 2 and -2. So let me label it here. Right? So suppose it's gonna go like this, right? Okay, and this number is this is related to the period, right? 2 pi over t. So again, whatever the numbers before the variable that you're interested in, that is 2 pi over t. Okay. So now 2 pi over t is 2, so the same as this one. And that will tell you that the period will be pi. So we know going up and down and back to the itself is pi. Okay, and now I have another piece of information, pi. What does this tell me? This tells me that my trig is shifted a little bit. It's a phase shift. So what does that mean? Let's see. In this picture, we know that the sign starting from 0 going up and down, right? So this is a general form for sine t. And this one looks like this way. It's because if you put 0 into t, if you get sine 0, we know sine 0 is 0. So that's why you can see this wave, this kind of shape starting from 0 when time is 0. But how about right now? It's slightly shifted, right? This is sine wave starting sine 0 equals to 0. But now you can see when time is 0 for this function, so if time is 0, 2 times 0 is 0, 0 plus pi is pi. You can see that when time is 0, whatever in the sine function is not 0 anymore, it is pi. So you can see the starting point is different. Okay, so this is starting point. This one will tell you where whatever inside this trig function, this will tell you where is this sign starting from. Okay, so now we have to look for the new 0. Okay. So what's the new 0? When will this be 0? This will be 0 when this be 0, that tell me that t is after some algebra, like t equals to negative pi over 2. So you can see that to make so this function, it's not really starting at t equals to 0 anymore. It's actually it is actually starting at negative pi over 2 to get this effective 0 point. So instead of starting from 0 and go up and down, now I will start at my new 0, like my new 0, which is negative pi over 2. So it would be here. Then I will go up. I'll go up, down, and then back here. And again, one cycle is pi. So negative pi over 2 plus this distance pi is pi over 2. So one cycle, this cycle will end at a pi over 2. Okay. So this is the function. This is the graphing looks like for this function. All right. So this is slightly more complicated case. So let's review on this piece again. For a general trig function, this part, the number in front of the trig function, this stands for amplitude. They will tell you how high is this function. And inside this trig function, that will kind of tell you like the squeeze, like the position and sort of like a spread out. Is it spread out or more squeezing? Like that kind of shape of a sine wave. And specifically, the number in front of the variable that you're interested in, this number is 2 pi over t, so that tells you about the period. Okay, and you can just set this guy in equals to 2 and get the period. So that will tell you how far it is for a cycle. And now the last part is the phase shift. this phase shift will shift the entire wave in the t position, in the t-axis. So how do we figure out how much it shifts? So it's not just shift pi, it's more than that. And to find out where it starts, where's the new starting point of this wave, we need to do a little bit of calculation. So first, we know sine 0 equals to 0, so this wave will start at 0 point. Now we need to find the 0 point, like the 0 point in this case. So when will this guy become 0? Oh, this guy becomes 0. It becomes 0 when the t is negative pi over 2. So this is effectively the 0 in this case. So which means my wave will start from negative pi over 2 and then go up and down, up and down, and up and down. Okay, so now I know it starts from here, it's gonna go up and down, but and then I know it's starting from here, and I know after a cycle, like after period pi, it will come back to itself. So let me figure out so I know the first point is here, but it ended at negative pi over 2 plus this distance pi. So it should end at pi over 2, should end up at this point. So I just kind of draw it symmetrically, go up and down, and that's my plot. All right, and so this is the way that I make a graph. Many people, other people may have a different way to do this. So I will post another videos on how mathematicians do a graph on this one. If this one does not make, if my way does not make sense to you, at least you have another source to look up for information. To manipulate a trig function, we need to use some, we call it the trig identities. So here I'm kind of just giving you the fact, and hopefully you have learned this in high school. If not, don't worry too much about it. These are just the rules or the fact that will be given to you, like either in the problems or whenever you need it. So these are the trig identities. Cosine theta plus pi is equivalent to negative cosine theta, and sine theta plus pi equals to negative sine theta. And if cosine negative theta equals to cosine theta, sine negative theta equals to negative sine theta. So these are 4 identities that will be useful. So when will we use these identities? Let's look into a question like this. So remember we just talked about the trig function in math. This is its general form. But in physics, we want to use this function to describe a physics phenomena. So we want to make sure all the variables, they have a physical meaning. So this psi will tell you the displacement of a wave. This is the amplitude. And this is the angular frequency. And phi will tell you the phase shift. All right. So in physics, because these two are physics quantities, this is not so much a physics quantity, but we do have a preferred range that we want to work in. Okay, so amplitude is like how far away it is from the 0 point, right? That amplitude. So it must be positive, not just real. It has to be positive to make physical sense. And so as the frequency, we know angular frequency must be positive, right? When you say negative frequency, what does that even mean, right? So frequency is also positive, and this phase shift, we also like to work it in a range where it is positive, and not only positive, it has to be between 0 and 2 pi. So this is the range that we like to work with. So now if I show you, I say, hey, look at this water wave. this water wave can be described by a function called 2 over 2/5 sine negative 2t plus 0.1. Now I will ask you a question. What's the amplitude? What is the omega? Like what's the frequency? And what is the phase shift? So amplitude is straightforward. Amplitude is just whatever in front of sine, and it is also positive, so it's correct. It makes sense. So it's 2/5. And how about omega? Omega should be positive, right? But here what I'm seeing is -2. So what's the frequency? Is it just -2? Doesn't make sense, right? We must turn it into a positive number. So how are we going to manipulate this function such that this negative sign will go away? Then we can try to use one of these trig identities. So let's see. There's a negative sign here. So let me try to use this. This one tell me sine negative something equals to negative sine theta. So I'm gonna massage this equation a little bit. Negative 2t minus 0.1. Negative sign out. And try to massage this. Looks like this. Okay, so this one I'll just make a bit more explanation here if this step confuses you. So what I'm doing here is that I want to factor out all the negative sign from this and that. So this one, if I factor out a negative sign, I will be left with 2t. This one, it had no negative sign, but we know like two negatives multiplied by each other, you get positive. So I can factor out one of the negative and still have one left. If you're not sure whether this is true, you can multiply this guy out to make a check. Negative times 2t is negative 2t. Negative times negative 0.1 would be positive 0.1. So you can see these two are the same. All right, this is just a trick. So let's come back to this problem. This is how I get to this point. And now if you can make a comparison between this format to that format, you can see this is nothing but my theta. Right, this is exactly sine negative theta. So negative sine theta, we know negative sine theta is negative sine negative theta is negative sine theta. So this would be this guy, this whole thing will become negative sine theta. So that will tell me that this guy will become negative 2/5 sine theta is now 2t minus 0.1. All right, so now we take care of this angular frequency, which is a huge thing. Okay, so now we know the angular frequency is 2. But you're like, oops, how about this? There's a negative sign here. Now my amplitude is not positive anymore. It was positive. Now it becomes negative. So what should I do about it? Let's use one of this identity to take care of this negative sign. So we used this one already. So let's try to look for another one. So there's a negative sign here. We know negative sine theta equals to sine theta plus pi. So this is your theta, right? So by using this identity, we will have this guy negative 2/5 sine theta equals to sine theta is this, and then plus pi. So this is my new format. Okay, so now this is good. This is positive. This is positive. And ever left, this would be a number, and this number, okay, is this number in this range? Let's see. We know that pi is like a 3.14, so this is roughly 6.28. And how about this number? This is 3.14, this is that, so 3.14 minus 0.1 is roughly 3.04, and this is exactly in this range. So this whole thing together will be my phase shift. So my phi, the phase shift in this case, will be pi minus 0.1. All right. So there's like a little, you need to like just kind of stick to your trig identities and manipulate it, find the right relations that may help you to change your format in a one that makes physical sense. So if you have time, feel free to try out this problem by yourself. After trying out, you can come back and compare the answer with me here. I will reveal the answer and show you how to get this. So I noticed that there's a negative sign here, and I know there's a negative sign, there's a plus. So I wanna kind of massage this one a little bit such that this part would be positive. And the trig identity that I can use is I can either use this one or this one because they all have negative sign in front of sign. So in this case, I choose to do this one. You can try another one, it doesn't matter. They should eventually give you the same answer. I'll try this one first. So negative sign theta, so this whole thing now in the bracket is a theta. If I apply this trig identity here, I'll end up getting 2 sine theta plus pi. Okay? So let me like massage whatever in this bracket a little bit. So again, the variables, I want to put the variables in front of the numbers. So this is the one with the variables, 3t. And negative pi plus pi would be 0. So that's it. Okay, cool. So it seems like one step is enough. So now from here we can see this is positive, which is good. Positive, that's good. This one is 0. 0 is within this range. So it's all good. So I now can write my answer. My amplitude will be 2. Angular frequency is 3. And the phase shift is 0. Okay. All right. And the next we will move on the trig addition identities. So these are some trig identities. If you add up two angles, and it will end up like this. If you do the trig addition, it will end up to be like trig multiplication in this case. So these are kind of like the rule of this trig, and so in this part I'm going to explain it to you how to use these trig identities to work out some questions like this. So let's see, if I have a wave looks like this and another wave look like this. If these two waves are on top of each other, I add them up, then what does it look like? Okay. And can you write the answer in terms of a multiplication form? All right. So let's see. This is two wave addition, so it's kind of like this. And I want to turn it into multiplication form, so which is kind of like this. So I'm going to use this identity in this problem. So now you can see my alpha is 2t, my beta is 3t, right? If I use this identity, I know that sine alpha plus sine beta equals to 2 sine alpha plus beta over 2. Alpha is 2t, beta is 3t over 2. Cosine alpha minus beta over 2. Now I just want to organize it a little bit. 2t plus 3t is 5t. And in this case, it would be 2t minus 3t is negative t over 2. All right. So that's my answer. And in this guy, what if I have a wave? This wave seems like a two wave multiplied by each other. How can I, decipher that and rewrite this form in terms of addition? Like, one trig plus another trig instead of multiplication. Right. So I can do it by one of these trig identities. I have a cosine sine multiplication, so I can either use this one, cosine sine, or I can use this one, cosine sine. So pick one you like and see which one is more useful. I'll probably go with this one first because it seems like very straightforward. It's multiplication equals to addition. So I'll go with this one. Now I know that 2x is alpha plus beta over 2 in this identity. Oh, sorry, minus in this case. And 3t is sine 3t. 3t is like this, play this row. All right. So if I use this one, then I know cosine this times sine this equals to sine alpha plus sine beta divided by 2. Okay, we need to divide it by 2 on both sides to get exactly this form. So I will get 1/2 sine alpha plus sine beta. All right, so what's alpha and beta in this case? We know alpha minus beta over 2 is 2x. Alpha plus beta over 2 equals to 3t. So this is the first equation, this is the second equation. All right. Okay. So now what we want to do is we want to figure out what's alpha and the beta. We know what's alpha and the beta in terms of some other variables. So now we are solving systems of equations. Okay, so how do I solve for alpha? I can there's many ways to solve this, but I'm just gonna do it in one way, in this way. So this is equation 1, this is equation 2. If I add up equation 1 and equation 2, I will end up on the left hand side. You will see this beta and this beta canceled, and I will have 2 alpha over 2. So that's alpha. So on the left hand side, I will have alpha, and on the right hand side, I have 2x plus 3t. So now I know what's my alpha. And I can do the same thing for beta. So to do beta, I will take equation 2 minus equation 1. Okay, so for those who are a bit rusty in systems equations, I'm gonna just write out more details in this here. If I do equation 2 minus equation 1, equation 2 on the left hand side I have alpha, so this one I can plus beta over 2 minus alpha minus beta over 2, right? And this one, I can rewrite this one as this. Alpha plus beta over 2 is equivalent to alpha over 2 plus beta over 2. And here, minus alpha over 2 minus beta over 2. So I just redistribute this 1/2 factor. And then I can see that alpha over 2 and alpha over 2 cancel out. Beta over 2 and beta over 2, they will add up because minus minus equals to positive. So this would be beta over 2 plus beta over 2. That would be going to be beta. Okay. So if I take equation 2 minus equation 1, on the left hand side, this minus this, I will eventually get beta. And on the right hand side, I will end up getting 3t minus 2x. So that's my answer here, right? Because my answer is 1/2 sine alpha plus sine beta. And sine alpha is 2x plus 3t. And plus sine beta is 3t minus 2x. So this is my answer. I successfully rewrite this multiplication form into addition form, into like two sine function add up each other. And you can see I'm not creating new variables. All the variables are written in terms of the given variables. All right. So it takes a little bit of practice to really get on to get familiar, to review or polish your trig manipulation skills. But basically, there are two big points that I want you to pick up here. One is use the trig identities to manipulate your function such that it's a physical function, that this is a function, it makes sense. Okay. So that's a little bit different from the math. The second part is trig addition identities. I'm not going to ask you some crazy fancy questions. You don't really need to memorize all these identities. But to know that two wave function add up together will be a multiplication of a trig function, to kind of know where it is coming from, this will help you to understand some format of waves in physics. Okay. So I hope you have fun with this, playing with trigs, and we will see more in the following lectures.